Smart Child Zone presents Rate of chemical reactions. The rate of a reaction is the speed at which a chemical reaction happens. During the course of the reaction shown, reactants A and B are consumed while the concentration of product AB increases. The reaction rate can be determined by measuring how fast the concentration of A or B decreases, or by how fast the concentration of AB increases. Every chemical reaction has a reaction rate. This is the time it takes to get from reactants to products. At a very fundamental level, we think about chemical reactions as being the result of particle collisions. How fast a chemical reaction occurs is called the reaction rate. Several factors affect the rate of a given chemical reaction. They include the following. When you raise the temperature of a system, the molecules bounce around a lot more. They have more energy. When they bounce around more, they are more likely to collide. That fact means they are also more likely to combine. When you lower the temperature, the molecules are slower and collide less. For example, food spoils because of chemical reactions, and these reactions occur faster at higher temperatures. Concentration is the number of particles of a substance in a given volume. When the concentration of reactants is higher, the reaction rate is faster. At higher concentrations, particles of reactants are crowded closer together, so they are more likely to collide and react. When a solid substance is involved in a chemical reaction, only the matter at the Look at the hammer and nails pictured in the figure below. Both are made of iron and will rust when the iron combines with oxygen in the air. However, the nails have a greater surface area, so they will rust faster. Some reactions need extra help to occur quickly. They need another substance called a catalyst. A catalyst is a substance that increases the rate of a chemical reaction. A catalyst isn't a reactant, so it isn't changed or used up in the reaction. Therefore, it can catalyze many other reactions. Pressure affects the rate of reaction. The rate of a chemical reaction can be found by measuring the amount of a reactant used or the amount of product formed over time. From the data in the figure, calculate the average rate at which a disappears over the time interval from 20 seconds to 40 seconds. We are given the concentration of A at 20 seconds, and at 40 seconds, and asked to calculate the average rate of reaction over this time interval. We can then use the formula. Because A is a reactant, a minus sign is used in the calculation to make the rate a positive quantity. Use the data of the figure in the previous slide to calculate the average rate of appearance of B, over the time interval from 0 to 40 seconds. Using the figure, calculate the instantaneous rate of disappearance of chlorobutane at t equals 0 seconds. To obtain the instantaneous rate at t equals 0 seconds, we must determine the slope of the curve at t equals 0. The tangent is drawn on the graph, as the hypotenuse of the tan triangle. The slope of this straight line equals the change in the vertical axis, divided by the corresponding change in the horizontal axis, which means change in molarity over change in time. Using the figure, determine the instantaneous rate of disappearance of chlorobutane at t equals 300 seconds. The tangent line falls from 0.100 to 0.055 in the time change from 0 to 300 seconds. When acidified hydrogen peroxide is added to a solution of potassium iodide, then iodine is liberated. As shown in the chemical equation below. Find the rate of reaction if the concentration of iodine rises from 0 to 10 raised to minus 5 moles per liter in 10 seconds. Suppose the concentration of a reactant in a reaction decreases from 0.8 moles per liter to 0.4 moles per liter in 10 seconds. Find the rate of the reaction. The concentration of a product in a reaction increases from 0.5 moles per liter to 0.7 moles per liter in 10 seconds. What is the rate of reaction? Notice we didn't use the negative sign, because we are dealing with the product and not the reactant. Consider the chemical equation. Find the reaction. The rate of reaction is measured with respect to change in product or change in reactant per unit time. The rate is 1/3 of the changes, because the ratio of the reactant and product of iodine ion is 1:3. Find the rate of consumption of nitrogen, and the rate of formation of ammonia. The first step in the production of nitric acid is the combustion of ammonia. Write the equations that relate the rates of consumption of the reactants and the rates of formation of the products. Considering the stoichiometry of this homogeneous reaction, the rates for the consumption Calculate the rate of reaction for 0.0440 gram of ethyl ethanoate, formed in 1 minute from a reaction mixture of volume 400 cm3. Step 1. Calculate the amount of ethyl ethanoate formed in mole. Step 2. Calculate the volume of Step 3. Calculate the concentration change of product formed. Step 4. Calculate the time in seconds. Step 5. Use the equation to calculate the rate. For more videos and other useful materials, visit us at www.smartchildzone.com/videos. Register your child and have access to our unlimited number of question and answer exercises. Visit www.smartchildzone.com.